Hello everyone, this side Anand Sharma. I am graduated and post-graduated from the Central University of Sagar, and I have total 4 years of teaching experience in physics as a CBSE board and JEE NEET faculty. Today we are going to study a very interesting topic in physics, that is periodic motion, oscillation and simple harmonic motion, that is called SHM. So let us start a very interesting session with this demo. Okay. So what is periodic motion? First of all, I will explain you what is periodic motion. Any motion which is repeating after an equal interval of time, that is called periodic motion. So we can say that any repeating motion, we will say that any repeating motion is called periodic motion. But one thing is compulsory in periodic motion, that those repeating motion are considered to be a periodic motion which are having equal interval of time, and this equal interval we will say that this is called time period. Okay, for example, students, you are going to school daily after 24 hours. So we will consider your going to school is a periodic motion with time period 24 hours. So any motion which is happening after a perfect interval of time, then that motion become periodic motion. Now we will consider what is oscillation. Oscillation is a part of periodic motion only, but condition is that in oscillation to and fro motion is important. Okay, so to and fro, what is to and fro motion? For example, this is a mean position, then the motion must exhibit exhibit plus a in this direction and minus a amplitude in this direction. For example, this is a mean position. If I go here, then come here, and then again equal distance here, this we will consider as a oscillation. So we can say that oscillation is equal to vibration also. Any type of particle which is vibrating in its mean position. What is mean position, bachcho? The motion is starting from any point, go extreme position in this direction and come back to the mean position, and again go maximum extreme position in opposite direction and come back again to the same mean position. This type of motion is considered to be as a oscillation because it is a part of periodic motion. Thus we can say that in oscillation this time period is same, है ना? This time period is must important here also, must important here also. Is it clear? Now we will talk about what are simple harmonic motion. Now simple harmonic motion is, we will say that simple harmonic motion is the topmost category of periodic motion, है ना? It is under periodic motion only, but very fine category. Now we have considered in periodic motion when a particle is exhibiting same type of motion again and again, we will say that it is a periodic motion. Now oscillation, what is oscillation? When the particle is exhibiting to and fro motion about mean position, that is called oscillation. Now if the particle is exhibiting oscillation in straight path, that is called simple harmonic motion. In this simple harmonic motion, this simple stand for straight path. Is it clear? For example, the motion of a spring, we can consider the motion of spring to be the SHM, because if we give force to this spring of mass m, the restoring force which will coming back will be F is equal to minus kx, and this will be the mean position, x is equal to 0, and this will be the negative extreme and this will be the positive extreme. So this is called simple harmonic motion. Any type of oscillation which is in a straight path, that is called simple harmonic motion. Now, the motion of pendulum. Some people say that the motion of pendulum is also a simple harmonic motion. But people don't know what is the condition when we accept the motion of pendulum to be the simple harmonic motion. For example, if the pendulum is having a very great angle like this, here and then here, then this pendulum will not be considered as a simple harmonic motion. Only the pendulum with a very small angle, small angular displacement like this, that pendulum, for example, for example, if a pendulum, this is a mean position for the pendulum. If a pendulum is having very much angular displacement like this, okay, this will not be considered as SHM. This will not be considered as SHM. Only the pendulum, for example, this is mean position. Only the pendulum which is having very small displacement like this, only the pendulum which is having very small displacement like this will be considered as a simple harmonic motion, because the path of this pendulum becomes straight when this angular displacement is very less. So what is our conclusion? Only the motion oscillating motion which are having straight path are considered as the SHM, simple harmonic motion. Now we will find out the acceleration in the simple harmonic motion. Now let us consider one simple harmonic motion, that is of a spring. For example, this is our spring, and this spring is of mass m. This is a rigid support, and this is also a rigid support, and this is frictionless. Is it clear? This is frictionless. Okay. Now if we apply some force, some stretching force in this spring, for example, if we apply some force F for this spring, now this F will generate a simple harmonic motion in this spring. For example, this will be the x is equal to 0, and we will get x is equal to a here, and x is equal to minus a here. This will be the type of simple harmonic motion produced by the spring, and this F will have value minus kx as the restoring force. Now we are calculating what is the acceleration of this SHM. For example, now force is equal to mass into acceleration, and force is equal to minus kx. Is it clear? Now, so what will be the acceleration? A is equal to minus kx upon m. Now we have already studied, sir, omega is equal to k upon m. Omega is equal to k upon m. Now the value of this k will be k is equal to omega square m. Now we will put this value of k in this equation. Now it will become minus omega square m x upon m. Now m enjoy, it will cut, and a is equal to minus omega square x. So this is the value of acceleration we get in a simple harmonic motion. Now one more thing, because omega is equal to k upon m, so our time period, what will be the time period? Now in next slide, let us take time period. T is equal to 2 pi by omega. Now we have already studied, sir, omega is equal to under root k upon m. Omega is equal to under root k upon m. Now this will give the value of time period, that is t is equal to 2 pi under root, and it will become m upon k. So this will be the formula of our time period. This is the formula of a is equal to minus omega square x, is the formula of our acceleration. Now you can imagine that, sir, the numerical value of acceleration is maximum at x is equal to a or minus a. So acceleration is always maximum when the motion is at the extreme point. Now I will explain the equation of velocity also in SHM, then you will do one analysis of SHM. Okay, now let us consider velocity of SHM. Okay, same SHM, now we will take velocity of same SHM. Now our acceleration is equal to minus omega square a. For this spring, this is the spring. If I say our spring is this is our spring, okay? This is x is equal to 0, and if you will apply this force F, then this will be the x is equal to a, and this point will be called x is equal to minus a. Okay, and this will be the mean position, and this F is equal to minus kx. Now a is equal to omega square x. Now we will say that dv upon dt is equal to minus omega square x. Now if dv upon dp is minus omega square x, now it will give, if we multiply dx upon dx both side, what we will get? Dx upon dx both side and minus omega square x. So it will give, sir, it will give this dx upon dt will give us a velocity. So dv and this x dx we will send here. Now v dv is equal to minus omega square x dx. Now we will do integration from integration. Now we will do integration like this to get the value. Now our integration will be from a to x. So why we are taking our integration from x is equal to a to x is equal to x, which x is not defined here. Now here, when the SHM is going to extreme point ax is equal to a, it will have velocity 0 because it will rest at extreme position and then it will come back to the mean position. So the velocity will increase from extreme to mean position. That's the reason why we are taking our integration from x is equal to a to x is equal to x. Now when we will perform the integration in both side, our velocity will be v is equal to plus minus omega under root a square minus x square. Now you people can see that the mode of velocity is maximum. The mode of velocity is maximum when x is equal to 0. We will say that the mode of velocity is maximum than when x is equal. Matlab velocity is maximum at the point where is our mean position here. So now now we will consider the real picture of SHM. The real picture of SHM is in the screen. The particle start its journey from x is equal to a and go to the extreme point x is equal to a at t by 4. Why I have taken t by 4 as a time when it is going to x is equal to a? Because if we consider them as any SHM of a spring or SHM of a pendulum, let's see here. First the particle will go to the extreme point here, then again to the mean position. This will be part 2, part 1, part 2, part 3 and part 4. So we have concluded that the SHM perform the motion in 4 parts. First it will go from mean position to extreme point at x is equal to a at time period t by 4. Now it come back to the mean position, that is x is equal to a at t by 2. Now it will again go to the negative extreme point, that is 3t by 4. Now it will come back to the mean position x is equal to a at time period, total time period t. Now in this SHM we will understand the points which are having highest velocity, the point which are having lowest velocity, and the point which are having highest acceleration, the point which are having lowest acceleration. The formula of acceleration is sir minus omega square x, and the formula of velocity is, sir, the formula of acceleration minus omega square x, and the formula of velocity is plus minus omega under root a square minus x square. Now we will apply this formula to conclude where is our maximum acceleration first. Okay, so our acceleration must be maximum when x must be maximum, है ना, और x will be maximum when our x is either x is equal to a or either x is equal to minus a. So we will say that numerical value of acceleration is maximum here and is maximum here. Now here if we talk about the velocity, now the velocity will have maximum value when x is equal to a. We are talking only about the numerical value of the velocity. Now velocity will be maximum here. Now if we consider acceleration at mean position, so at x is equal to 0, acceleration will be 0, or we will say that a will be 0 here. And if we consider velocity, now at the mean position, if we here put x is equal to a or x is equal to minus a, we will get velocity as 0. So at x is equal to a or x is equal to minus a, velocity will be here 0 and here also 0. So this is the picture of acceleration which we concluded. So what is so this is the picture of SHM that we concluded, starting from mean position and come back to the mean position. So this was Anand Sharma signing off.